How's it going, everyone? Welcome back. So since the last video, I've actually implemented a lot of extra functionality, which I'm actually impressed with. I thought it'd be a lot harder to do to set up the contracts and to mint the NFTs through Amazon, but it turns out it's actually pretty easy to do with everything I have kind of put into place and all the prototypes that I've done in the past to just pull that code in and get it working. So what I want to show you is the UI and kind of walk you through the features that I've added, and then kind of also dive into the diagram that I always show, and then the implementation details if you're interested in learning more about that. So this is the UI running locally right now, and what I want to show you is I can actually go and upload a zip file, which I think I might have demoed before, but I'm going to show you the entire process at this point now. So I think this is actually pretty cool. Let me go ahead and click on a file. So this NFT zip has 2 NFTs in it, which are just pictures of that egg NFT collection I made a while back. And when I click upload, that's going to upload it to an S3 bucket, invoke a trigger. The trigger is going to pull that zip file, unzip it, and then move every individual JSON file and JPEG file into its own S3 bucket, and also create a DynamoDB entry, which I kind of talked about in the last videos of the series. So at this point, when your job has been like processed and is kind of ready to go forward to the next step, as a user, what you can do is you can click a pay button. I haven't actually implemented the Web3 MetaMask to kind of like ask for confirmation and to approve funds to be transferred. But the idea is that when you click the pay button, it's going to show you the MetaMask wallet. You're going to enter in whatever the estimated cost is for in Matic, so 0.17 in this case. And again, every time you refresh this page, it's going to change based on the gas prices of the Polygon network. So right now, I haven't implemented all that logic. It's kind of mocked out. So when I click pay, I'm assuming that the person has already paid. The transaction is good. Let's just go ahead and click pay, and I'll show you what happens. Again, there's a lot of stuff that I can kind of, polish up. For example, like, although I press the pay button, there's no feedback. What I should probably do is hide the pay button, or show a spinner, or show an alert saying that your process is being, your batch is being minted. So right now I'm just going to refresh the page just to kind of show you that logic. So when the thing is actually minting, actually this one says it's done minting, so that was actually pretty quick. So when it's actually done, what I want to do is dynamically change the UI to show you some of this stuff, but you can actually click on this to go to the Polygon's Mumbai testnet, and you can see that the contract was created here, and then we minted 2 things here. So that's pretty much all there is to it. I can kind of share the code, but let me just make sure this works. I'm going to go to that transition, or that transaction, and I'm going to go and look at some of the data that was sent over. So you can see here we have the user who owns the actual NFT. We have the token of the NFT, and then we also have a URL. So hopefully, if I were to go to this URL, we should see an image, or actually we should see the JSON metadata, which we do. And inside of that JSON metadata, if I were to look at this image, we have the image of the NFT that has been deployed to IPFS, and that's also all set up, ready to go. Now, a cool thing is I can go into OpenSea using that contract. So if I go back to my UI here and copy this contract, basically, I can go to my contracts here. So let's go to my collections, and I can click on these 3 dots and say import from existing smart contract. I'm going to say live on testnet, and then I can actually enter in that contract address here. My page would load. So enter that in, get rid of those extra spaces, which I copied over an accident, and then click on the Mumbai. So click submit. And now on the testnet, I can actually import my collection, and it has my 2 NFT images right here. So everything is working fine. I don't know what this 8F7X thing is. I don't know if maybe there's a bug in my code that's causing this to be deployed with whatever this is, but everything seems to be working. Yeah, so one thing I want to change is when you press the pay button, I want to show maybe a modal or another screen that asks you to name your collection, maybe give a symbol for your collection, and then also the default address of who's going to own your NFTs when you mint all of them. So I'm really happy with the progress that I made. Like, we're creating a contract for the user. We are minting the NFT images for the user. We have all those things uploaded to IPFS. All that functionality and features are working fine. And let me kind of explain what's going on behind the scenes if you're interested in learning more about that. So again, the best way to kind of explain some of this stuff is by going to the high level diagram that kind of outlines all of this. And you'll notice here, everything that's in green, I've actually implemented. It's working, and it's working to the best extent of my knowledge. I'm sure a lot of this has bugs, but basically what we just implemented, or what I showed you. So in the last video, I kind of showed you that, we got to this part where we had this lambda that was unzipping the files. And then in this video, what I kind of added on since then, or maybe I already talked about this, I don't know, but we added a pay endpoint where basically you can attach a transaction to a job ID. And then when you do that, we're going to try to verify that the payment has been accepted. I haven't actually implemented this stuff yet, so the user can't actually pay for it, which you've seen in the UI where it doesn't work yet. But basically, the API is going to be invoked, and then if everything is good, if the transaction has been paid, we are going to fire off another trigger or another Lambda here. So actually, one thing that I don't have documented is there's an actual a queue here in between all this. I could try to put this like here so you can kind of tell. But basically, this API is going to create an event and put it on a queue. And that queue is going to be consumed by this, what I'm calling the contractor. The contractor basically takes an event off of the queue, and then it's going to deploy your contract. And if everything is good, it then injects a bunch of events into this mint queue. All right, so the mint queue, what this does is it takes every single event, and then it's going to invoke a Lambda, which basically fetches back the JSON file, and it also fetches back the PNG or the JPEG or whatever image format that you uploaded, and it pushes both of those to IPFS over here and does some updates behind the scene to make sure your metadata file reflects the image location where it's hosted on the IPFS gateway. And then when that's all done, we are basically calling the mint function on the contract that we deployed for the user, and just updating a couple things in Dynamo along the way. There's probably another line I need to draw here that goes from here all the way to Dynamo, but you kind of get the picture. We just keep track of some state of stuff is processing when stuff is finished. Honestly, the last steps are just these lines in red, which might take me a day or two to figure out. But all in all, I mean, I think it's pretty much there. There's a lot of stuff that I'm kind of concerned about. For example, when I'm minting contracts, I saw that my wallet got like locked up for some reason. I don't know if I didn't pay enough gas or my transaction just never got processed, but for some reason, like every time I tried to deploy a new contract or upload a new zip, it just wouldn't get past this step. And I'm kind of concerned that if people are actually using this application and they try to, you know, upload zips to be minted, that there's going to be points in the process where the Polygon network says, hey, something went wrong and I need to figure out that error handling, which is going to be, yeah, so I'm kind of concerned about like if something goes wrong when trying to deploy or mint an NFT and the Polygon network refuses it because I ran out of gas money or I didn't pay enough gas money or something, then I need to account for that. It's going to be a lot of work trying to figure out the errors that could potentially happen and how to rectify those situations. Another thing I'm kind of worried about is if the user pays not enough gas money, I don't want to keep on minting based on the money that I have in a wallet. Because how this is working behind the scenes is that I just have basically a single wallet that's used behind the scenes for this entire system. And when a user pays, they're basically just putting funds into that master wallet. And when they're minting, it's just taking funds from that master wallet and using it to mint the NFT. So at some point, if gas prices keep going up too high, it's going to drain my wallet of all the funds that they paid and additional funds that happen to be in the wallet. So I need to kind of make sure that that doesn't happen. And also let the user know that like, hey, sorry, gas prices went up when you're minting these NFTs. You're either going to need to pay more money or you can't mint this collection anymore. So hopefully with using a queue here in Amazon, I'm also using a dead letter queue, I can tell when these NFTs fail to mint, and I can just go back and reprocess them if I want to in the future. So I did want to kind of share a little bit of the code that I've been working on to get this stuff all working. So it's good to start with the serverless file. So there's a couple functions that we're using on this serverless YAML. Basically, the first one is the API. This is the express application that's allowing people to pay for their NFT collection to be minted, and also for them to be able to get a pre-signed post URL. The unzipper is the Lambda that we kind of talked about, where it takes the zip file that the user uploaded and just unzips it and moves those files to another S3 bucket. So next we have the contractor, which basically takes an event and will deploy a new Polygon contract when the user has actually paid for this whole process to kind of continue forward. And then finally we have the minter, which will just take a single image, mint it, mint the JSON file, or upload the JSON file, upload the image to IPFS, and then mint the item for you in Polygon. And then down here, of course, we have all the different queues that are defined. We have like the contractor queue. This is an SQS queue. It also has a dead letter policy. So whenever it tries to process an event and that event fails, it basically puts that event into a dead letter queue so that I can go back and see that, hey, there's stuff failing. People are trying to actually use this application, but for some reason their processing is failing, Polygon's failing, something is failing, and it gets put into a dead letter queue so I can go back and kind of understand what's going on. And then we have the unminted queue. Again, that's the this queue right here. I do need to come back and kind of update some of the names. But this is the unminted queue where it takes unminted images and mints them on the Polygon network. So that's pretty straightforward. Again, this has a dead letter queue so I can keep track of if things fail. I'm using a first in, first out queue for these just because I want to make sure I process these in order. Mainly because I want to make sure that the nonce that I'm using on my Web3 like wallet inside the system can be incremented correctly one by one. And I was worried that if I try to run all of these as fast as possible, the nonce might get out of sync. I don't really know. I need to do more testing about that, but hopefully this works. And of course, we have the Dynamo table down at the bottom and some environment variables. All right, so some of the Lambda functions, let's look at the code and how this kind of works behind the scenes. So we have one called the contractor, again, which basically gets an event, and then it's going to set up a wallet using a mnemonic. I don't know how to pronounce that word, but basically it's like a string that contains some words that kind of describes what your secret keys are going to be, and it's used to sign the transactions, I guess. It basically, what that does is sets up the wallet, sets up this Web3 thing with the provider, and then it gets the first account that's in that collection of accounts. And then we loop through all the records that come in. We basically try to fetch and figure out what the priority gas fees are so that we can actually get these minted at a decent rate. Right now, I'm just using the standard fees because, you know, there's not really a high priority, but maybe a user can pay more if they want to do a higher priority for minting these things. But basically, I get the gas station fees. I figure out how much the, let me see down here. I figure out how much the max priority gas fee is and also the max fee per gas. And then I basically just get the contract. I deploy the contract here. And then at some point, over here, we actually send the contract to Polygon, right? So this is how we send it and pay for that contract to be sent up. I wasn't too sure if I could just wait on this. Like, I did some hackery to get it to actually know when the block has been confirmed. I might come back and try to figure out a better way to do this because it seems kind of hacky. Because I had this other like wait for block function that basically just does an infinite while loop to check if the block has been confirmed. But from reading the docs, I should just be able to do like an await on this method, and that should automatically just wait until the block is confirmed. So I'm kind of confused why I had to do all this code to get it working, but it works. I committed it. I'm just going to leave it alone for right now. And then finally, we update some Dynamo DB records, like such as the contract transaction hash and the contract address. We delete the SQS message, and then we do some more stuff. All right, so this part is actually pretty important. Basically, it's doing a query against Dynamo to get all of the NFTs that we haven't minted yet. And we loop through those one by one and create SQS messages and send them to that unminted queue that I kind of talked about. So that's, at this point, there's another Lambda that's going to pick those up over here. And let's kind of walk through this one real quick. So kind of similar to the last one, we kind of set up a wallet, we set up a provider and all that jazz. And then we loop through all the events that came in. We, again, do the same thing with the gas station, like estimates for how much stuff is going to cost. I need to come back through and refactor a lot of this code because it's not really clean right now. But what we do is we get the actual individual NFT job from the DynamoDB table, and we basically fetch the image that we're trying to mint. We, create a hash by uploading it to IPFS, and then we kind of do some hackery to get rid of the suffix and replace it with JSON so we can then fetch the metadata object, right? So then we fetch the metadata object, and then we parse it. We replace the image property with the new hash that we had just created a second ago. Then we upload that one to IPFS, right? And then finally, after all that's done, we will create a new contract object, which allows us to call a method on it called mint. And by calling mint, we can pass it the address that we want to own the NFT. We pass it the kind of the unique identifier for that individual NFT. And then we also pass it the metadata URL, which happens to be hosted on IPFS as well. And then we pay for it. And after all that's done, we basically update Dynamo and say, hey, like this NFT has been updated, it's been minted. We also like keep track of the hash image, the metadata hash, and the transaction hash, just in case in the future I need to look those things up. And then we actually update another Dynamo record to kind of keep track of when we're done minting all of these, right? So if you're minting 10,000 NFTs, at some point you're going to have like 10 left, then 5 left, and finally you're going to have none left to mint. So we kind of just decrement a counter on Dynamo by 1, and then if that remaining is equal to 0, we know that we're fully done with that collection, and we basically just update the status to done. And that's why in the UI you can see that it went from status of processing to status of done. And then finally we delete the SQS message from the queue. So that wraps up the major update that I did with this project over the past couple of days. Again, it's a lot of cool features that I think can actually almost put this product in the hands of consumers if they want to actually use this. I'm not 100% sure if this thing won't crash if people start hammering this, but hopefully it works and I can actually get 1 or 2 people trying it out. But if you enjoy watching this video, give me a thumbs up. Also, leave a comment below if you have any feedback of features you want added or things that you can suggest that I can do to kind of make this project better. And like always, be sure to click that subscribe button and bell icon if you're interested in more content like this that should hopefully help you become a better web developer in the future. All right, have a good day and happy coding.